Now that we know what an inequality is and sort of three different ways to represent inequality kinds of information, the only thing we haven't done is actually apply what we know about solving equations to the process of trying to solve an inequality. So we haven't answered the question yet, what score does Rhonda need to get on this third exam in order that her average for all three exams is at least equal to 70? So what do you think? What might be a way for me to move forward on this inequality to try and get this x by itself? So according to our equation solving strategy, the first thing we should be thinking of is simplifying both sides. Simplifying, I should say, each side of this equation. So is there anything I can do to make the expression on the left-hand side here simpler?
Would it make sense to start off with 3x and then you'd add the two averages that you have?
Okay, let's do that. So let's simplify the arithmetic that we're seeing on the left-hand side by at least, first of all, adding together the scores for the first two exams. Right? 78 plus 54, that's going to give me 132. So I'll end up here with 132 plus x, all divided by 3. Okay, so we're getting a little simpler now. Anything else we want to do with this expression over here? I can think of maybe one more thing that we would want to do before going forward. Yeah, let's take the addition on the numerator and split it into two additions of fractions. Right? We're going to undo the addition by common denominators. In other words, turn this into a division by 3 in both of those two terms. Greater than or equal to 70. And then we can actually carry out the quotient, 132 divided by 3. That turns out to actually be a whole number. That's 44. So that makes our life a little bit nicer. Okay. So now I have an equation, 44 plus x over 3, an inequality, 44 plus x over 3 greater than or equal to 70. That if I want to get that x by itself, I've now simplified each side of this equation as much as I can. I don't need to do any variable collecting because my variable x is already only on one side. Okay? So step 1 is done. Step 2 is done. My only step now is to reverse the order of operations. So in this inequality, what would that look like? What would my first step be if I'm following SAD-MEP? Subtracting 44. Great. We want to do all the addition and subtraction that we can first. And here that means subtracting 44 from both sides. That's going to give me x over 3 on the left-hand side. It's going to give me 70 minus 44, which is 26 on the right-hand side. Okay. Now all of my addition and subtraction is done. Now it's a matter of multiplication and division. So what can I do to get this x by itself? Multiply by 3. And why is multiply the right choice?
Because x over 3 is a division.
X over 3 is a division, right. It's x divided by 3. So to undo dividing by 3, we'll multiply by 3 on both sides. 26 times 3 is going to give me 78. And now my x is by itself. And what you'll notice, as advertised, is that an inequality problem has an inequality solution. Right? And the solution to this inequality is x is greater than or equal to 78. How do we take that and put the context back into it? What does this mean about Rhonda?
78 is the lowest you can get.
Yeah. So she needs to get a 78 or higher, right? As you said, it's the lowest score that she can get to get that 70 average that she's looking for. But she could get more and still have a higher average than 70. Right? X greater than or equal to 78. Before we wrap this example up, let's also translate that back into interval notation, which for me always involves this pit stop in a graph first. So if I were to graph on a number line the inequality x greater than or equal to 78, first of all, which direction from 78 would I want to shade? To the right or to the left? I would shade to the right. We know it's right because greater than or equal to. Right? So we'll shade to the right of 78. And then at 78, do I want a hollow circle or do I want a solid circle? Solid, because we're going to include the number 78. And we know we want to include the number 78 because greater than or equal to. And I like this as an intermediate stop because then this shows me how to write my interval notation for this inequality. What's it going to look like? I need a lower endpoint, I need an upper endpoint, and then I need either brackets or parentheses. First of all, what's my lower endpoint? 78. What's my upper endpoint for this interval? So there's a mathematical answer to this, but there's also a practical answer to this. The mathematical answer is, how far up does this interval go? Infinitely far. But what would the practical answer to this be?
100.
Probably. If this is an exam that is scored out of 100 points and there's no extra credit, you could make the case, in context of this problem, that 100 is an appropriate upper limit. Let's go with infinity for now, but we'll also look real quickly at what it would be if we wrote 100 up there. Okay, now let's decide on the square brackets or round brackets. Do I want a square bracket or a round bracket on 78? Square, because 78's included. So Rhonda can get a 78 and get the average that she's looking for. Right? So 78 is a part of the puzzle. Is infinity included?
No.
Never. That's right. So that always gets a round bracket. So there's the mathematical answer in interval notation. But what if we were being practical about this and saying, well, if this exam is out of 100 points and there's no extra credit, how would that change our answer?
You have a square bracket instead.
I would have a square bracket because why?
Well, 100 is included.
Because 100 is possible, right? It's the actual number that could be an x that solves this inequality. So the practical answer to this is she needs to get a 78 or better, but she really can't get anything bigger than 100 if the exam is graded out of 100 and there's no extra credit. So not only did this turn up an example of why we would care about inequalities, and also notice the process that we used to solve this inequality was identical to the process that we used to solve equations. There's one exception to that rule that we didn't quite get to today, so we'll catch that up in our next class. But also it surfaced the difference between solving a practical contextual problem by paying attention to context, which we did here, by saying 100 is the upper limit, versus just paying attention to what the mathematics says, which sometimes gives you a different and often more expansive answer than you were looking for.